Hi, all, good morning. In this project, we have built a model to predict the electrical energy output of a combined cycle power plant, which uses the various different data sources such as the gas turbines, steam turbines, and the heat recovery system generators to generate the power. We had nearly around 9,500 observations, which includes the hourly average ambient environment readings from the sensors of a plant. Um, so these variables are typically the temperature denoted by T, ambient pressure denoted by AP, relative humidity denoted by RH, exhaust vacuum denoted by V, and a predictor output which is the PE or the energy output. Now, the modeling approach that we have used here is the multivariate regression algorithm, wherein these three models were being picked, built, and compared based on the various feature selections. The models were built on a train and a test data sets, which train has about 84% of the 9,500 records, whereas the test has 16% of these 9,500 records. The train and test data sets were arrived basis the random sampling. The key metrics that were being used to determine the best model is the mean absolute error and the mean absolute percentage error. There were insights related to the exploratory data analysis, then the model output, and the business outcomes. So this sheet or the exploratory data analysis talks about the descriptive statistics as a one part, which talks about the mean, the minimum, maximum, standard deviation, the standard errors for each one of these variables. Then on the right hand side is the correlation matrix, which has the correlations between each one of the input and the output variables. What we see is that the exhaust vacuum and the AT has a high positive correlation of 0.84. The exhaust vacuum and the PE has the highest negative correlation of minus 0.88. AT and PE have a high negative correlation of minus 0.05. Then this is the summary of the models that were being built. This table compares each one of the models with respect to the R square, mean absolute error, and the mean absolute percentage error. Then these were being built on a trained data sets and then applied. The model that has been applied were on a test data sets has the mean absolute error and the mean absolute percentage error being compared as well between the models. So what we see is that model 2 is performing better than any other model in a sense that it's able to capture the variability of R square at 0.93 better than the other models. Then model 2 has the lowest mean absolute error and the mean absolute percentage error compared to the other models. Then the key significant variables from this particular table talks about the Innova table talks about the RH, then V, and then P, then the AP values. These values, if we look at that, majority these values are very minuscule in terms of P values, which is less than 0.05. And what from this particular table, what we see is also that the way we can interpret this particular table is in terms of business outcomes. With every 1 unit increase in the ambient pressure, there's a 0.06 increase in the energy output. Then with every 1 unit increase in the relative humidity, there's a 0.16 decrease in the energy output. And then with 1 unit increase in the exhaust vacuum, there is a 0.22 decrease in the energy output. This particular sheet is more of a working sheet of this Model 2, which also has details about the absolute the way the mean absolute percentage error and the mean absolute percentage error has been calculated. Then we had this particular model being built on the test data, which also we see that there's a these key metrics has been determined. The MAPE, which we talked about, is 0.8%, which is in a way that accuracy of this particular model is at 99.2%. Yeah, then there are other sheets like Model 3, Model 4, and there's a models that was been built on a full data sets. But as of now, what we've seen from a summary standpoint, the Model 2 has been better than any other model, given this as the MAPE and the mean absolute error as well. That's about it. Thanks so much.